All right, good morning. This is the initial check your understanding questions for the central limit theorem. So among iPhone users who share their data with Apple, the weekly screen time is skewed right. So that means our population is not normal. There is your population mean and standard deviation. We have a random sample of 100 iPhone users. And so the first thing I always like to do is I like to make sure that I pull out my parameters so I can just see them clearly. And then I'll also need the sample size, which is 100. And so describe the shape of the sampling distribution. Well, this is approximately normal. And to justify that, I'll invoke the central limit theorem and I'll list the sample size. Because the sample size is large enough, 100 is clearly greater than or equal to 30. So we'll use the central limit theorem. And that'll justify normality in this case. So for B, find the mean and standard deviation, and notice here, of the sampling distribution of X bar. And so the mean of the sampling distribution of X bar is just the population mean, 13.5 hours prior to calculating the standard deviation of the sampling distribution. We will need to check the 10% condition. In this case, again, we don't have the number of iPhone users specifically, but we can say definitively that 100 users is definitely less than 10% of all iPhone users. And so the 10% condition is satisfied by this statement. Now we can proceed to calculate the standard deviation. And so the formula for the standard deviation of the sampling distribution of X bar is going to be the population standard deviation divided by the square root of the sample size. Here is that plugged in, and we obtain 0.375 hours for that standard deviation. So now that we have that information, we can tackle part C, which asks us to calculate the probability that the weekly screen time for the sample, this is how you know to use the sample statistics, is between 12 and 13 hours. So you notice I've labeled here my normal curve. This is again the mean of the sampling distribution and the standard deviation of the sampling distribution. And we're looking for a value between 12 and 13. And so you'd need to calculate two z-scores. Here is the formula for the z-score. And we're going to calculate the z-score for 12, which is -4. That's very small. And for 13, it's -1.33. Here's your standardized distribution labeled with those values. And then using the normal CDF command, the lower bound would be -4, upper bound -1.33. Of course, for the standardized distribution, we'll have mean 0 and standard deviation 1, yielding a probability of 0.0918. And I hope this helps.